Hello everyone, welcome back to Express VTU for all. Today we are going to solve a very important problem from module 2, joint probability distribution. The question is the probability distribution table for two random variable x and y is as follows. This is our given table. What we have to find, determine the marginal probability distribution of x and y, obtain the correlation coefficient between x and y. So first we have to find the marginal probability distribution. How can we find? By adding the respective entities of rows and respective entities of column. So for x we have to find first. So for x, this is our row 1, this is value for 1 and this is value for 2. So what our xi value is 1 and 2 for x. So this is 1 and this is for 2. What is f of xi? Then what is f of xi? So 0.1 plus 0.2 plus 0.3 is 0.6. For 2, 0.1 plus 0.1 plus 0.1. Sorry, 0.2, 0.1, 0.1. This is 0.4. So this is marginal distribution for x. Now go for y, like that. This is nothing but y of j, j times of y of j. So this is -2, -1, 4, 5. So for -2, what is value? 0.1 and 0.2, which is 0.3. Then -1, 0.2 plus 0.1 is 0.3. For 4, which is 0.1. And for 5, 0.3 plus 0, which is 0.3. So this is our marginal probability distribution for x and y. Now go for our second question, which is correlation coefficient of x and y. So here we are using a formula to find correlation coefficient of x and y, which is correlation of x and y, which is equal to, we can write it as p of rho of x of y, which is covariance of x comma y divided by sigma of x into sigma of y. So first we know what is covariance of x and y. After that we know sigma of x and sigma of y we have to find. So now first go for covariance of x comma y, which is nothing but expectation of x and y minus expectation of x into expectation of y. So we have to find this one also, because we don't have expectation of x and expectation of y. So how we find expectation of x? By the marginal distribution of x, which is, we can define as mu of x, which is equal to expectation of x, like that, 0.6 into 1, 1 into 0.6 plus 2 into 0.4, which is equal to 1.4. Here I am writing directly, but here we are using a formula x of I into f of xi, because we have to multiply 1 into 0.6, 2 into 0.4, like that. So this is our expectation of x. Now go for expectation of y. Now go for expectation of y, which is y of j into g of y of j. So here -2 into 0.3 plus -1 into 0.3 plus 4 into 0.1 plus 5 into 0.3. So -2 into 0.3 plus minus 1 into 0.3 plus 4 into 0.1 plus 5 into 0.3. When you calculate it, it becomes 0.6. This is minus 0.3 plus 0.4 plus 1.5, which is equal to 1. So what is our expectation of y, which is equal to 1. Now go for expectation of x and y, which is equal to, how can we find the expectation of x and y? From the mean table. So expectation of x and y is given here. So 1 into minus 1 into 0.1 plus 1 into minus 1, sorry, here 1 into minus 2 into 0.1 plus 1 into minus 1 into 0.2 plus 1 into 4 into 0 plus 1 into 5 into 0.3. Like that for 2 into minus 2 into 0.2 plus 2 into minus 1 into 0.1 plus 2 into 4 into 0.1 plus 2 into 5 into 0, like that. This is the way we have to find expectation of x and y both. So we are writing here summation of xy, yj and j of ij, which is 1 into minus 2 into 0.1 plus, this is 0.1 plus 1 into minus 1 into 0.2 plus 1 into 4 into 0 plus 1 into 5 into 0.3 plus 2 into minus 2 into 0.2 plus 2 into minus 1 into 0.1 1 plus 2 into 4 into 0.1 plus 2 into 5 into 0, which is equal to minus 0.2 minus 0.2 plus 0 plus 1.5 minus 0.8 minus 0.2 plus 0.8 plus 0, which is equal to 0.9. So this is our expectation of x and y, which is equal to 0.9. So to find the covariance of x and y, we have, so to find the covariance of x and y, we have expectation of x and y and expectation of x and y, both the values we have. So now we have the value of covariance of x and y. Now go for sigma of x and sigma of y. So sigma of x we have to find, which is equal to sigma square x in expectation of x square minus mu square x. So here how we find expectation of x square? Expectation of x square nothing but summation of x square I into f of xi. So we have to square this one and multiply this one for finding the expectation of x square, means 1 square into 0.6 plus 2 square into 0.4. So 1 square into 0.6 plus 2 square into 0.4, which is equal to 2.2, like that. So now what is the value of mu square x? We already find here. Mu of x is 1.4. So we already find mu of x, which is equal to 1.4. So what is the value of mu square x? This is nothing but square of mu x, which is 2.2 minus 1.4 whole square. So which is equal to 0.24. So what is the value of sigma x, which is equal to 0.49? Now go for sigma square y, which is equal to expectation of y square minus mu square y. So in the same way, we have to find the expectation of y square. How can we find the expectation of y square? We have to square the y term and multiply to the g of yj, means minus 2 the whole square into 0.3 plus minus 1 the whole square into 0.3 plus 4 the whole square into 0.4 plus 5 square into 0.3, like that. So first we find expectation of y square, which is summation of y square j into g of yj. So minus 2 the whole square into 0.3 plus minus 1 the whole square into 0.3 plus 4 the whole square into 0.1 plus 5 the whole square into 0.3. So when you solve it, it becomes 10.6. So expectation of y square, which is equal to 10.6. Now we have to find mu square of I. So already, now already we have the value of mu square y here. Here we have the value of mu square, mu of y, which is nothing but expectation of y, which is equal to 1. So by the data, sigma square y, which is equal to expectation of y square minus mu square y, which is equal to, what the expectation of y square, we already got 10.6. This is 10.6 minus expect mu of y is 1, then what is the mu square y, which is equal to 1 the whole square. So 10.6 minus 1, which is equal to 9.6. So mu square y is equals to 9.6. So mu y which is equal to, sorry, this is sigma square y equals to 9.6. So sigma y equals to 3.1. So now according to the formula, we already find covariance of x and y, sigma of x into sigma of y. So now put all the values in the formula to find the correlation of x and y. So correlation of x and y equals to covariance of x comma y divided by sigma of x into sigma of y. So what is the value of covariance of x and y? So covariance of xy, which is expectation of x into y minus expectation of x into expectation of y. So expectation of xy, we have 0.9 expectation of x and y, and what the expectation of y, which is equal to 1, and expectation of x, which is equal to 1.4. So 0.9 minus expectation of x is 1.4, expectation of y is 1. So which is 0.9 minus 1.4, which is equal to minus 0.5. So covariance of x and y equals to minus 0.5. So put the value of covariance in this formula, we get minus 0.5 by sigma of x, we already know, which is equal to 0.49, and sigma of y 3.1. So 0.49 into 0. Sorry, this is value of which is equal to 3.1. So 3.1, and you solve it, you get minus 0.3. So covariance of x and y, which is equal to minus 0.3. This is our final answer. So thank you for watching our video. Please subscribe Express VTU for all.